Итак,
So, what are we going to speak about? You all know
так гораздо лучше.
that's much better. You all perhaps know that in addition to development analysis means in our company we do a lot of penetration testing. And we declare to market and our clients that, hey guys, for us it's not a way to earn money because the profit from penetration tests compared to selling Max Patrol and other ones, it's a part of a percentage. For us, pen testing is first of all material for the research. Which vulnerabilities we discover in the informational system of the client, how these vulnerabilities can be used in order to break and hack the informational systems of our clients, why these vulnerabilities are produced, how can we remove them, how can we work with them, this, and this, and this. So this is material which comes the input to the analytics so that they could lay the foundations for the solutions which are developed by our programmers. Statistics of such projects we are publishing constantly, and from year to year the statistics are very similar. 90% of pen tests, while the main objective is to get control over local computer of the client or over the certain IT system, 90 or more % of such projects are coming to getting this control. In 2 cases out of 3, in order to break the system and become the domain administrator deeply in a local network, you shouldn't leave the office all the time. So the perimeter is penetrated from outside, then you get control over certain points inside of the network, and then practically our guys, without leaving the office, become internal violators for this particular network. But perhaps in 2-3% of the cases we are not able to get a full control, but very often it doesn't mean that the system is protected and well defended, but we just have reduced the scope. For example, at the perimeter you can see 1,000 hosts, you take only 2 of them, the rest of them don't touch them even though they have vulnerabilities. So, with this in mind, what do we see? There is a networking perimeter which is viewed as some kind of wall, Chinese wall against the local network of the client, and to protect the perimeter they invest the main amounts of money, in addition to simple things like domain authentication and other things. So on the perimeter we see the firewall, web application firewall, IDS key, and everything which has to be ideally help us to discover the hacker attack. Nevertheless, approximately 90% of the cases perimeter has been penetrated, and 60% of our work is we break it through vulnerabilities of web applications or by brute forcing of the passwords to the interfaces. In other cases we have to use social. Social science works all the time and has never failed us. We never had a case when we're unable to find users inside of the network who will open a letter that was sent to them, and this user at the working place will always have a certain number of vulnerabilities which will help us to get control over his computer. With this in mind, if the 6 to 7 years ago, in order to break the informational system, one had to strongly tune up the toolset for himself in order to analyze the protectedness of the Wi-Fi network, you had to compile the Linux kernel, then you should tune up the drivers of the wireless cards. Right now toolset is so simple that even a schoolboy can work with it. We had a case when I've been speaking with a pen tester girl with a very good experience of doing pen tests, and she was telling how she was catching passwords in a network. I start KNL, I press the button, here they had the passwords. So it's hard-proofing. How does it work? I don't know. She didn't even know how the protocol Ethernet is built, how it works, why it works this way. She just presses the button and she's a profi. In some cases, we truthfully have to work a lot, but nevertheless, especially in order to having the access to the router to reveal the tree of routing in the network, it's not a basic objective, and this can be done only by qualified specialists. With this in mind, when we do work Well, the clients, of course, knows that pen tests will be done, and it will be done in this period of time. And of course, IT guys, they don't want to fail, and they try to do their best. They try to know the activities of the hackers, and they try to stop them. But with this in mind, the pen testers' activities, they can be discovered only in 2% of the cases, and very often the result of accidents. For example, we've been brute forcing the passwords, an account has been stopped. What happens? Oh my God. And some inaccurate movement with redirecting the traffic inside of the network, and traffic just stopped moving. Everybody start cleaning up what did happen. Irrespective of the fact that clients has ideas, has a lot of means and instruments which should help them to catch the hacker attack at the early stages, they don't work. And organized counterfeiting, we didn't see like the attack has been noticed at the early stage. Then they started the alarm, and people have determined what really happens and where does it come from and what is to be done in order to stop this criminal activity. There were cases when in server room, they have been working in the server room. He has his console, he tunes up something, and then he sees a message on the screen, Metasploit message window. Our guys already work inside of it remotely, and he sees some strange numbers running through it. He gets scared away. He reloads the server without telling anybody about it. Security guys learn about it from us because we say, hey guys, see, the server was reloaded. We assume that it was noted, and we inform them that this activity did happen. Even though it should be vice versa. Security guys should tell us, hey guys, we have noted you. The set of problems that we see on the side of the clients is the similar set of problems, and it's a result of the pen testing. We can list with big level of probability. We can tell you in advance the results of this vulnerability of web application. It's a common problem. The problem of passwords and protection, 3% in any company, respectively to how well you have set up the domain policy in the company. And complexity of the passwords, 3% of users, due to different reasons, they use word passwords. For example, administrator has given this password to them, they don't change it. Also, usage of unprotected protocols inside of the network, at least. For example, to convince Cisco guys that Cisco has to administer to SSH and not Telnet, and sometimes they don't understand why this should be done, etc., etc., etc. So, making a resume of everything said above, we know in advance which set of problems, which set of errors are done by people who create a network, create the informational system, and exploit it. And we, as a rule, in advance do know how can we use these problems in order to penetrate this network. At the same time, this is a technical side of the question, but there's also ideological side of the question, why the defending side is not able to fight against the hackers attack. One of the problems, and it's a very serious problem, especially for the big companies, very often the defending side doesn't know what they should defend. The security guy of the big bank, he knows that he has the ABS, automatic banking system, you know, all the passwords, and he knows nothing about this banking system. The maximum he knows that IT guys have told him the list of the servers which are the part of this informational system. BIS, Banking Information System, and he knows that this system is made on a DSoft 4.4, but which models are part of the system, he knows nothing about it, and he never learned to use them. And very often the defending side doesn't know about which informational flows are running between the servers, which relations permitted and which are not permitted, and which has to be looked at as anomalies, which data is being transferred, which routers and commutators are using in the process of transferring this data, etc., etc., etc. Very often, security guys in the company learn about how the systems, well, they learn from our pen testers when they have analyzed after the pen test, post-pen test analysis. Well, this is one side of the problem. The second side of the problem is that defending side very often doesn't know how the attacker behaves. They read the standard model of the violators. You see, hacker can... Well, knowing the project documentation of the system, hacker can find vulnerability in it. Well, knowing the source code, hacker can find vulnerabilities in it. But which toolset has been used, which possibilities hacker does have and which doesn't have, he doesn't know. Which set of activities usually is being taken by, for example, there's an application, there's well-known types of vulnerabilities, and how can you find the SQL injection and how to exploit it, and which logs will stay after these activities. Well, the defending side does not know about those things. So all the set of tools which is needed to discover a hacker attack is available, but if the hacker is not noticed until the moment when somebody will not inform, hey guys, the main portal was defaced and your money are leaving the client's accounts and you don't even know about that. So I'd like to say that the root of all these problems, the problem is rooted in the fact that reacting to attacks principally is different from preventing attacks. And usually security guys are defined for the second one. In order to prevent networking attacks against certain protocols, it's enough to put a firewall which will cut out 90% of the vulnerable protocols while 10 will still stay. But in the case with reacting to incidents, it doesn't work. You can defend yourself only from those, you can correctly react only to those incidents which you are ready for. You do know how the DDoS attack is being done, so you have been thinking about where you have located and where you place the sensors and which types of events from these sensors you will perceive as a non-standard ones. Moreover, in addition to react to the attack, you don't just need to properly note it, but you also have to know what is to be done, who should be raised, and how much time do you have in order to react and to remove the attack before the network will fall. So you have to know three things. In order to properly organize the reacting to the attack, you should know what are you protecting, how your information system is built, and from which components it consists, from whom you're defending yourself, who is the violator, and you should also know which set of signs you should perceive as the effect of attack. And there are certain difficulties here, because if you will react to everything, you will have too many false positives, and at the end they will tell you, hey guys, you just take a lot of our time and nothing happens. But if you will have a very high threshold, you will pass the attacks, and then reacting to incidents will not be effective as well. So as a consequence, what do we do right now? We are developing the product line which helps you to solve all these problems. Well, I'm not going to advertise them. We have announced them to our clients, but the main principles which are inbuilt in their operations, well, I'm going to tell you about them. So the first that we face when we communicate with the client, there are clients with very competent security guys who do know in principle what do they want to get and from whom they are defending themselves. But it's probably 20%. 80% of the companies, when we talk to them, we face situations, very common myths that, well, our system is isolated from the external world. Well, I can believe that, but honestly speaking, you know, from the experience from real life, I can see totally different situation. Or when we speak that common user can redirect the traffic and find the password of the user, they say, well, our users are not so competent to do that, even though I know several accountants who've been entertaining themselves that from their colleagues in the accounting, they've been catching their passwords of Vkontakte, Odnoklassniki, and other social systems. Yeah, they were sisters and relatives of our employees, but nevertheless, this qualification is sufficient, and you can expect it from different people. In our pen testing group, we did have very qualified specialist who, by his education, was a financial revisor, not IT guys. You know, breaking was his hobby that he was having during his free time. So what do we see in reality? The production management system, we see that there's an office segment, everything in separate VLANs, processing of plastic cards, or system separated in a separate VLAN, there is no routing between them, and client thinks that interrelation is impossible and computer attack is also impossible. Well, the topology does not permit them for that. But if you look at this automated process control system more carefully, you will see that in Office VLAN there's an administrator who's just too lazy to run from one building to another to retune, reset the server. So his workstation, he was added to the same VLAN where the administrated system is located. Yes, direct routing between these systems is not available, but his machine became trunk between them. So we get the control over this machine, and the next step, we already have the networking access to the SCADA system. Hello Semantics, hello Honeywell, hello vulnerabilities that you have, which are well known since 1990s in the operating systems of these particular vendors. As a result, it happens that representation of the system as it is seen by the client an operator of this system while looking at the networking schemes, looking at the project documentation, it's really different from what is available in reality due to the same human factor, mistakes, laziness, etc. So in order to defend yourself, you should understand that this bi-level attack is a normal thing in life, and that in a second of all, you should understand how really the equipment is being preset in your company and whether this attack is possible, which is the route of the attack. So in the result, if you will look at certain more or less complex organization, you will be able to see that there's a lot of entry points out there, and they are different. For example, same industrial company. They have a segment of production process management. We expect in our model of violator, we expect that evil Buddha hackers will have a desire to local or international conflict, and somebody would like to make a diversion attack. And honestly speaking, these threats also should be looked upon. But nevertheless, which are possible ways of attack realization? Well, the stupidest way is getting connected to telecom channels in the segment of APCS, automated process control systems, or the equipment is being transferred to the wireless management. So using those wireless protocols, and as a rule, in principle, they don't have any mechanisms of protection because, first of all, they are connected for the speed of data transfer and minimization of delay. This is the most obvious way. It doesn't work very often because there is control zone, outside of which radio signal you will not be able to catch it and you will not get access to the radio system. But nevertheless, okay, you cannot do it directly. The office network, and theoretically it is separated from the segment of the automated process control system, but the same human factor wrongly set up a firewall machines which become trunking between two networks, etc., etc. So we get the access to the office segment, for example, in a result of the external attack, or if you're employee of the same company. Then you go to the segment of PCS, automated process control system, and for the management of the equipment, they use kiosks, where the terminals that work in kiosk mode, and user cannot do anything clever with them. He has the interface and he does only what is permitted, but it's interesting. But there's a lot of vulnerabilities which allow to get around this kiosk mode to get to the command line and use this terminal as a regular computer. If you cannot do it this way, there's a more complex way, the attack from outside with the usage of social engineering to the desktops or the office segment, or with the usage of vulnerabilities of web applications or errors in remote access settings on the terminal servers of the office segment. As a result, the attack against the end automated points are good attacks against well-known vulnerabilities. Therefore, in order to model the behavior of the violator, you have to know these typical vulnerabilities. You should know how they are being used and know which tool set should be used by hackers against that. And the volume of knowledge is a very big one and requires certain qualification. So what do we know about violators? When we read certain model of threats of a certain commercial company or the state organization, we do see that violators can be employee of special services which can influence the producer and put a certain software insert into the equipment or into the operating system. Well, in the practice, in real life, when we truly want to build normal reaction to the threats, as the head of my previous company have told, be practical, he said. We should look at some practical assumptions. You can assume that the attacker will use some clever possibilities and clever software, but we should come with an assumption that a violator is a 20, 30-year-old young person with a very high level of curiosity, and he uses tool set which can be freely downloaded or you can buy for very small money. But yes, these tools can be expensive, but it's in free distribution, of course, with certain assumptions. So if we will take for the basis this particular assumption, then the tool set that is being used by the hacker becomes understandable. Then Metasploit, Harley Canvas, Sunsploit, well-known set of exploit packs with well-known content, with well-known exploits and well-known vulnerabilities, plus tools of binary analysis of files or the analysis of the source code, but once again there is a certain set of methodologies which are used. There's no magic behind it. There's no magic behind it, so when the person looks and finds vulnerability, no, there's a certain set of templates you enter to a certain site, which is well described in the articles of binary analysis of files, search for their vulnerabilities, buffer overflow, protocol phasing, etc., etc., etc. Yes, I will not reproduce it. I'm not a hacker. I'm an analytic. But nevertheless, I can list all these methods, and I do know approximately which traces are left after using those tools. With this in mind, what defending side forgets about is when we're getting ready to react to the hacker's attack, we should know that hacker has certain objective. He's not just in vain breaks the system, he wants to get something out of it. Very often, the attack is built in a common way. Step number one, get access to anything. And then to the weakest points, and these weak points we know: web server, terminal server, desktop of a user, because you can easily get in connection with them. Then develop the attack, and then there are two well-known ways: is to increase your privileges by using local vulnerabilities, become an administrator, or by using arm spoofing attacks, DHCP server, redirect the traffic to it, then catch up password of the administrators and other privileged users, and then use those passwords to get access to the informational resources. That's it. We became enterprise administrator or the admin of the Cisco, and the system is ours, and we can do whatever we want with the system. The objectives are understandable, results are understandable, tools are understandable. This is one side of the question. The second side of the question is, what are we protecting? And there is a problem here. The problem is following. There are different people who are interested in defending their system, and they differently look at it. For the business, the threat is losing money. Before and even the exclusively losing of the money. Sometimes a loss of the reputation, but it's still loss of the money. But indirectly, IT guys, for them, it is important the operability of the operational system. They don't really know about the financial part of the financial consequence, but they don't know if this server will fail. Then, in the best case, somebody will be fired. A security guy thinks in the terms of which have been taught in confidentiality violation, properties of information, availability, and some people know properties like integrity, reporting, etc., etc. Hacker, pen tester, or hacker attacker, he thinks totally differently in different categories: vulnerabilities, attack, result, development of the attack, and more advanced result. And in order to understand what do we protect and from whom, all these approaches have to be united somehow. How can this be done? Of course, naturally speaking, we should start looking at the system with the eyes of the business, because it makes no sense to protect the test system if it has no influence, and the attack against it will not lead to anything. Yes, agree? Who would argue? Therefore, first of all, we should understand which information systems should be protected, and which of them are important. Step number one, which information systems are interesting for the business and they have to be protected. Step number two, which of the systems can really be interesting to the hacker. For example, the system of reporting for the bank, system of reporting to the central bank is very important for sending the reporting for 2 days in advance. Well, this is the foundation of canceling the license. For the hacker, it makes no sense to break the system if it will not become the intermediary stage for attacking the remote banking servicing system. So, first of all, we have to look at the business. We should look at the business results, and then we should identify the main informational systems. Step number two, we should look at the system with the eyes of the IT guy. We have an identified system, yes, very good. Then we should understand from which service it consists, which informational flows are running between them, etc. Step number three, we should look at the system with the eyes of the hackers. Because once again, in the perception of those people who develop the defense, it's considered that a hacker looks at how the information system is built, and he knows which joints to attack, which points to attack. But it means nothing for the attacker. Attack system is a black box, which he doesn't know how it's built. For him, it's just a set of routers, servers, working stations. First step, he attacks something which is vulnerable. Second step, he attacks its neighbors, gets control, and step by step he gets more and more control. And in order to get complete control of this, he starts to understand which profit he can get from this. Oh, this is a remote banking service system, and I become an admin of this system. I wouldn't say that it was funny and interesting, but my favorite incident in the year 2012, it was an attack against one of the American processing banks, when the attack was done the following way. So the guys sitting in their apartment from a Fortune Top 100 magazine, they took a list of the most rich processing companies. Then they went to their internet site, they found vulnerabilities of web applications, then they got inside, and then suddenly they control traffic, but they know nothing what to do with it. They started looking for colleagues who could write specific sniffers, which could not just listen to the traffic but define transfer of card dumps and then pull these dumps. They were not ready for getting control over the informational flows with the card dumps which could be sold on the black market. So for them the system initially was a black box with weak interface which they could use. So respectively, if at the moment of modeling the defense, we should bring together two approaches. So looking at the system from bottom up, we should identify the key points of entry, key vulnerable locations for the client, and then we should look at the system bottom up. And we have always Zoo used by the company, hardware Zoo, in order to get control of these key entry points. We can use these desktops, these routers, and these particular servers. But for example, the same test server, which ideally is not interesting for the hackers, can be located in the same VLAN as a remote banking service server. Simple step, and they lock credit calculators. They're located in the same segment. We attack credit calculator because for the business it's not interesting, it's vulnerable. We get control over it. Then we are in a similar network, and then we can catch traffic from the remote banking service system. So therefore, inventory bottom up is built in the following way. First, you get information about all the assets of the system. You identify all the networking points of entry. After getting all the information about them, after analyzing the configuration of the routers and switches, you build a topology of the network. Then you understand how the network is built into VLANs and not how it is defined in the project documentation, and then how the information flows are built, and not how it should be tuned up for the firewalls, but how it really works. And on the basis of this information, you group points. For example, you have the key informational system and auxiliary servers to it. You look at it as a single point because it's a single object of attack from the hacker's point of view. And then we take into consideration the info flows, because you have to understand where the protocols of control are running around and where the identification data can be used of privileged users, which as a hacker we would like to catch while doing the attack. So what does it mean, the inventory of the entry points? Well, you have to identify them, first of all. You have to identify those points differently. If you scan network with Nmap, you see the network as just set of IP addresses. If you scan it with the help of more advanced scanner, which can analyze configurations, the inventory for us will become a set of the software that is installed on those computers, the set of vulnerabilities which are available for penetration in this software, configurations, networking configuration, configuration of the security functions, because very often we can see errors which are used by the hackers. And by the way, in pen testing, very seldom we use exploits to the binary vulnerabilities. Very often only misconfiguration works pretty well. Improperly configured elements, and this is related to the following fact. Users don't permit to use exploits if something will not work, and with this limitation we have to use exclusively vulnerabilities of web applications, architectural errors, and errors of settings of certain components. But therefore, after collecting this information, we get initial data in order to build possible ways of attack against such a system. separately. It's building the topology of the network, and there's a mass of tools which can do that. For example, when I started to work 18 years ago in this field, I've been using network manager, which with SNMP was scanning configurations of the routers, switches, workstations, desktops, and I've been building topology, but it was building topology on the network level of the model on the third level. And most of the accessible tool sets, they work in the same way. But honestly speaking, you should take into consideration the mass of equations, the same second channel level, because only the analysis of routing, all these bad trunks, you will not be able to find them. This can be done only by analyzing connection of ports of the routers to certain VLANs. If you would like to analyze whether you correctly set up the firewalls, you have to take into consideration SLAs on the routers and settings of rules of filtration on the firewalls, but as a rule, it's a transportation level. In addition to that, very often they use firewalls of the applied level, WAF and other ones, so you have to take into consideration connectedness on applied level. In addition to that, very often we see the presence of solutions when the data sets are being pulled through different protocols. For example, control of the industrial equipment. We have a Modbus protocol which works on the end devices, on field devices. However, it is being broadcasted as Modbus TCP in the network. The same data is being transferred, and in the route on Modbus TCP there may be no vulnerabilities, but if you pull data afterwards, you can exploit vulnerability directly in the hardware settings. Or when you use the systems like, for example, portal of state services, when we feel the application PDF application is being sent through the HTTP protocol, it's been downloaded to the service server, extracts data from it, and sends it to the database control system. Well, for us, it's a possible but difficult way of exploitation of SQL injection. SQL injection is injected into PDF. Web server will transfer this SQL injection afterwards. Extremely difficult to use, but I can illustrate sometimes it is possible, but it's not enough to analyze the level of data transfer, but you have to analyze it's not enough to analyze networking components of data transfer, but you also have to analyze the pathway, how the data is being pulled into the processing server, and sometimes it's a very difficult way, different pathway, different route. The most important thing we face is a misunderstanding of threats themselves. So you take the railroad transportation control system. There's a train control system. They are all automated, so the machinist, he does a lot of things, but he follows the signals which are given to him by showing different lights. So from the security point of view, threat, there's a lot of documents about it. The threat of railroad transportation are the same violations of confidentiality, generally speaking. Well, it should not work like that, because we cannot adequately react to the attack if we don't understand what's going to be the result of this attack. So there are two situations. We have received control over the light, and we can give a certain light, green, red, or yellow, which consequences it may lead to. From the point of view of classical security, is the violation of integrity, and there's no difference from anyway. So if you will give green light, for example, the entrance lighter at the station, it would lead that the train is on the station, the second train doesn't stop, and there's human deaths, etc. In the same situation, if you will give constant yellow light, this will lead to the fact that the second train machinist will see the signal, will be able to stop, he will see the tail lights of the stopping train, he will stop on time. Yes, this will block it's going to be financial transfers to the, but it will not lead to the human threats. And you also should take in consideration the context where these devices located, which we were able to break and attack. Yes, in the case of the station, it will look this way. If you will give green light, lights which are covering section of railroads, one side railroad, it may lead to the situation that two trains will enter the same block, and there will be implosion of the trains with the if you will give yellow light, both trains will go head to head. They will not break, but they will block the railroad without human deaths. From the railroad point of view, it's much worse for the railroad, even though it's cynical, because you will have to pay compensation to the who didn't arrive on time. Well, in the case if these trains will block the movement will stop in the railroad, and these are billion losses for the transportation company. From business point of view, it's much worse than collision. of trains. So in order to be ready to understand how fast we can react to various attacks, you have to properly understand the technology of what is being defended and what really happens in the business system. And defending side cannot do it alone. They have up to apply IT guys, technological specialists. For example, in the railroad transportation systems, charters are written by the blood, and they're also been written by the blood. There's a certain set of threats which are defined in the legal documentation of those railroad companies, and all these situations which can lead to human deaths or to the stoppage of the railroad transportation, they all are defined. The same with aviation transportation, the same with chemical processes and chemical factories, oil processing factories, and pipelines, etc., etc. As strange as it may seem, irrespective to the fact that we are hackers and pen testers, even we have to learn about it when we do this analysis of defense. Therefore, we do know which consequences this attack may lead to, and in a given case, transfer of the switch under the train when it passes to a certain railroad, and we know that this attack cannot be done by one single move because the system is isolated. In order to do this attack, one should do a certain sequence of actions. So after we have done inventory of the informational system, we know from which components it consists, which networking segments, what and how it is set up. Looking at all of this, we can build graphics of possible attacks. Yes, being outside, we cannot immediately influence the microprocessor system of controlling the railroads. But the step number one that we can do, we can get access to the working station of the dispatcher on the station. Why? Because this bad guy periodically puts 3G modem into his station in order to play tanks. For example, as soon as he puts this 3G modem, because he has access to the internet, it means he is subject to social engineering, and to his working station we can download, exploit. Yes, it's going to work. There's not going to be a constant connection. It's going to work periodic, but it's enough to do the attack. If we can download the exploit on his workstation, it means that we can try to do our spoofing attacks, or if we see that on the spanning tree protocol is not being filtered, we can reroute the routing inside of the network, and we can catch traffic, for example, traffic of the FTP protocol through which they communicate. One system is being controlled. If we can get access to the FTP protocol, then we could put our own hardware, software. We see the guys who work in the railroad who are related to this system. We find the binary analysis, then we customize the software, then it does what we should do. Each step like this is understandable for us because the source for it is our knowledge about how the component is built, our knowledge about typical errors that are done on this component, and our knowledge about typical ways of using this and exploiting these errors. So we can model all possible routes of the attack by building this graph simply by collecting and analyzing information from the informational system. So if we want to be ready to react against the attacks, we should have a certain tools available. So we need the inventory. The inventory in the network is done the inventory is done by simple scanners. For example, Max Patrol, by using the protocol of controlling equipment, WMI for Windows, SSH Telnet for networking equipment, etc. It's able to collect information about vulnerabilities, about configuration, software installed, etc., etc. But nevertheless, the idea of the possibility of automating the inventorization of the network came to us along the way while we were developing the Max Patrol scanner. Therefore, putting it against the network, putting the scanner against the network, we can collect a lot of information that we need to build a graph of attacks and to understand how the system is built and what we're protected from. Therefore, in order to discover attacks, Yes, there's a system of discovering the attacks, and possibly it can be divided into two classes. It's based on signatures and based on discovering the anomalies. Both of them have their advantages, pros and cons in the system. The system is based on signatures. It works against well-known exploits, but they don't work. They don't work against certain classes of attacks. So we, for example, had a situation when a client. So we did a pen testing, and the client at that moment of time, security guys were looking at IDS logs. So very good IDS manufacturers, they didn't know how to catch out spoofing attacks. Well, these signatures were defined in them, but they just didn't give these warnings. We didn't learn why, but the application has left to the manufacturer, but there was no reaction. The systems, of course, have a lot of those attacks which have no other signatures through which we can know this attack when it's being done. The system of discovering anomalies in other way are able to find the attacks just because the attack is a little bit different from regular traffic flow between different known systems. But there's another problem, is the false positives. Every false positive, every false warning about the attack, it's labor force. The more labor force you spend, labor which doesn't give a visual result, it's unhappiness of the business because we need people, they need to pay salaries to those people. And if the person just sits and looks at false positives, why do we need this person? So none of these means of detection of injections will not give you 100% protection from the attacks. However, if you will bring together IDS with the inventory system, you can find a lot of interesting things. Why? Because inventory system, from them you know about vulnerabilities which really are present given the moment of time in these info systems, and for these vulnerabilities, as it is well known, we know there's an end set of well-known ways of using these vulnerabilities. Moreover, the set of tools which can use these vulnerabilities. Application of each one of these tools in each of these vulnerabilities gives us well-known typical footprints that you can discover in the network traffic. Therefore, analysis of the network traffic, if you don't have an objective of searching for certain signatures, you can make it into a search of footprints of well-known attacks. So we have two data sources which you can compare one to another. In addition to that, there are logs which give you a lot of useful and good information. For example, the same IDSs, they can discover password brute forcing. From one connection, you have a big number of wrong authentication attacks. Well, this is a simple brute forcing, and brute forcing is not done this way due to application of IDS. And for example, there is a technique of temporary blocking of the account when we know 200 of the accounts of the users of the system, and we know that after 3 attempts of password setting, the account will be blocked for 20 or 30 minutes. We do know that this counter after 2 attempts will be dropped after 20 minutes of inactivity. And there is a password technique when you make 2 attempts. 2 are non-successful, then you go to the next computer, you take the list of most common passwords, so you take 2 passwords, you take then you wait 20 minutes before the counter is being zeroed, then you test 2 next passwords. This way gives you possibility of getting 3% of users which use word passwords, word-based passwords. And thanks to clouds, thanks to Amazon, thanks to resistant systems, we can rent certain number of machines in the cloud which have totally different IP addresses and totally different geolocation. I'm not speaking about botnets which are applied for this particular purpose, and these attacks will not be coming from a certain particular point. So there's no signature which would allow the network IDS and the networking perimeter to identify this attack as a brute forcing attack. But this information will be seen by logs in the service and applications. Therefore, network analyzers will be added to the log collection system. So we have 3 sources of data which allow us to analyze these attacks from 3 different vectors. So in order to compare all of this, you can use systems, CM, event correlation systems, and these existing systems have one vulnerability as a limited integration. Yes, they can work with scanners of vulnerabilities. Yes, they can analyze log. Yes, they can work with analyze traffic. But the problem is that due to the fact that these systems are developed by different manufacturers, they use different formats of messages, different data composition, and developers of CIEM have different limited capabilities from the point of view of integration between themselves. So CIEM can decompile and parse the message from which is coming from IDS, for example, but not all this data which is present there can be usefully used. For example, the experience of Max Petrol with ArcSight. ArcSight takes information from well-known vulnerabilities and he cannot do anything else with it. But truthfully speaking, in the XML document that we give to them, there's a mass of other interesting things. And there's a software, there's information about settings, etc. But due to the fact that ArcSight in the integration part where the analysis of vulnerabilities is set up for, let's say, average possibilities of the scanner, this information is not being taken because they are not going to set up for the additional capabilities of another solution, not their own. So we need to have a CIEM which can maximally fully work with all available information which comes from all these sources. The second problem of SIEM is that the correlation of events is done in a universal way. So roughly speaking, we calculate the number of events of a certain type. When we exceed a certain threshold, we see the trigger working well. We have an incident, we have to react. On the previous slide, I've been showing you that we can build attack graphs. So we have the end set of vulnerabilities and ways how these vulnerabilities can be used, and traces which are left after these attacks. If we would have a database of knowledge which would contain and compare all of this, then CIEM could use correlations based on attack types. Very often, sequential activities of the hackers are not perceived as a single set of activities, and we had a brute forcing of the password, but in this case we had exploiting of local vulnerability. There's no sign which could a priori define the rules of correlations which would look at these actions as two steps of the same chain of attack. If we do have graph of attack, we know that after brute forcing of the password, possibly we could have 5 options of attacks, and a local exploit is step number 4, let's say. So we can, on the basis of this base of knowledge, we can connect 2 of these different events into a chain of attack, and we do know where this attack has started. It started from the brute forcing of the password. We know how it was continued. It was continued by exploiting local vulnerability, and we know which possibilities hacker has received. He became a local admin on the computer, and therefore his set of attacks, his vectors of attacks are extended by this number, by adding this, and these attacks. This gives us a possibility to automatically include additional rules of correlation and follow which other signs of the development of the attack we can find in our network afterwards. Therefore, this base of knowledge, upon the results of pen tests we are developing and we inbuild into the product that we propose to our clients. We do the correlation of events, and it allows us, this software allows us to identify attacks against the informational system. As a result, what do we have as a result of all of this? Right now, this is a prototype which works on our basis, and we show it to the clients. It's a unified system on a single platform, which introduces everything: the scanner, DPI, correlation of events, product and base of knowledge of vulnerabilities, vectors of attacks, hackers, tools, etc. Thanks to all of these being united into one platform, yes, you cannot defend yourself from everything, but you can defend yourself from those things which are well known, and a database is being updated constantly, and by doing this, we free the operators of the system from manual low-level coding of the rules of correlation. So well-known way of using the vulnerabilities is being automatically becomes into a certain database of correlations how to discover to different data sources the traces of this or that attack. Smart correlation. Therefore, just a second, we'll try to formulate my next statement. Yes, therefore, due to the fact that upon the results of this inventory, we know not only those points, but the topology of the network, including the connectedness on the applied level, knowing that hacker right now has done an attack against this particular point of entry, we do understand which other points become available to him after this particular point. After seeing the attack against the demilitarized zone point, we can immediately warn the administrators, database managers, which is located in an internal network, which is not accessible to the hacker. But we know that there's connectedness on the data transfer and the possibility of exploiting the same SQL injections, and therefore you should open your eyes and see maybe something strange happens to your server, because right now you will be attacked, because right now there was a successful scanning and we see download of the web shell to the web server, which works with your database, with your DBMS, and it helps us to build the correlations to the extending attack in the process of its realization at its early stages. Therefore, in the result, we get a single platform on the basis of which we build a system we call Security Operations Center, SOC, a structural subdivision which follows what really happens on the perimeter of the company, what really happens inside of the network. Then they discover traces of attacks and then makes decisions on the basis of this particular information. So we get a coordinator inside of the company. So if previously security department was writing papers, was following that admins would properly put the function of security, this tool set allows you to make and create inside of your security department a subdivision which will be responsible. It's some kind of warning group. You have discovered a hacker attack at the moment when hacker just have found the first vulnerability and first entry point and tried to use it, and you stop it. It helps you to remove the problem of lack of professionals inside of your company. If you look at some ministry in the central office of this ministry, it's a big problem to create a department which would have well-qualified specialists able to discover those attacks. Somewhere in remote city where the population of 20,000 people and they have a territorial division of this ministry, qualified specialists, well, it's impossible to find them. By creating such a division which is on a centralized basis monitors the whole infrastructure, we basically can, from a single point, we can not just discover the attacks, but we can help people on locations, in remote locations, if we know that hackers at a certain moment of time to the server located in St. Petersburg attacks systems which is located in Novokuznetsk. We can not just inform them about this attack, but we also know what kind of attack is happening, and we also know what is to be done in order to prevent and stop it. We can get in touch with respective people in Novokuznetsk city, and we can inform them, hey guys, can you block this particular port, says that there is a mistake of the configuration of this component, replace this parameter by this parameter. And this will allow us to quickly neutralize those attacks. Ideally, of course, it's understandable that it has to be, the organizational structure has to be defined for this, and for big companies it's very problematic, but nevertheless, for the telecom operators, these centers, reaction centers already been created and work very effectively. And by the way, not only in Russia, but also the divisions in Russian regions, they discover and react to attacks which come from Indian subdivisions of the same telecom operator. Well, basically, that's all I wanted to tell you. Thank you very much for your attention. If you have any questions, I will readily answer them.